Hello everyone. So let's solve a LeetCode medium problem today. Minimum operations to make all array elements equal. So the problem states that we are given an array nums consisting only of positive integers. Now we are also given an integer array queries which is of size m. And now for each query we want to make all of the elements of nums equals to the queries of I. So in each query we will be given an integer, and now we need to modify this nums such that all the elements becomes equals to that element. Okay, and for making the element equal we can perform the following operation on the array any number of times. So we need to increase or decrease the element of the array by 1. Suppose we are given an array nums and we want to make it all elements equals to x. That means for all the elements in nums which are less than x, we will be increasing them to make it equals to x. And for all those elements which are greater than x, then which will be greater than x, then that means we'll need to decrease these elements to reach x. Okay, so we need to return an array of size m where answer of I will be the minimum number of operations required to make all elements of the nums equals to this particular x. And we need to find for each query, means each query will be giving us a different element, and now for each query we need to tell the minimum number of operations required to make all elements of nums equal to that particular element. And it is given that after each query the array will be reset to the original state. That means we need to for each query this nums is independent only. Okay, so let's see the input here. So we have 3168. So for x equals to 1, what do we want? We have the nums as 3168. Since we want the array as 1 1 1 1, this is the final output that we want. So how many operations we'll need to perform here? We'll need to decrease it by 2. Okay, for this we'll need to, it will remain the same, so 0. For this we'll need to decrease it by 5 operations, and for this we'll need to decrease it by 7 operations. So then the total number of operations will be 7 plus 0 plus 5 plus 2, that means 14. Similarly, now when x equals to 5, for the second query we have x equals to 5. So we want to make 3168 to 555. To make it 5 we'll increase it by 2, so plus 2. To means to make it 5 we'll be applying 4 operations, so plus 4. For this it will be applying 1 operation. Okay, and for this we will be applying 3 operations. Okay, so we'll be decreasing by 3. So the total number of operations will be 2 plus 4 plus 1 plus 3. That means total we need to apply 10 operations, and that will be the minimum number of operations required. That means all elements which are element, if it is greater than x, then we simply need to decrease it. Okay, and if element is less than x, we'll simply need to increase it in each operation till it reaches x. Okay, similarly in this case we want to make all the elements as 10. So for here we'll increase 8 times, for here we'll increase 1 times, for here we'll increase 4 times, and for here we'll be increasing 7 times. Since the total number of operations will be 20. So what will be the most naive way or the brute force way of solving it? For each query we'll simply try to make all the elements equals to that particular query of I. So what we'll do means for each query, suppose query of queries, suppose we have the current element as x. Okay, now what we need to do, we need to move I from 0 till n minus 1, and each step what we'll do, initially the operations count is 0, and we'll be increasing our operations by what count? It will be the difference between x and the element that we have, nums of I. Okay, so if nums of I is less than x, then we simply need x minus nums of I, and if nums of I is greater than x, we need nums of I minus x. That means simply we need to find the absolute difference. Okay, so hence the operation will be increasing by absolute of nums of I minus x. And simply once we have calculated this, we will simply push, create a vector of result which will be returning the result for each of the queries, and we'll simply push this result operation in our result, and simply finally we will return it. So you can see the time complexity will be, since this will go till big of m, and this is we are going till big of n, so the overall complexity will be n into m. And let's see the constraints as well. So we see that n and m can go up to 1e5, so the time complexity will be till 1e10, which will obviously give us TLE here. So let's see the proper code first to get the understanding about this approach. So we create this long vector result which we need to return. Now we iterate through each queries. Now the current cost that we need initially is 0, and we'll iterate through nums and increase our current cost by absolute difference of the values, and we simply push it in our result and return the result. So this will be the TLE approach for this problem. Let's try to submit it and see how many test cases does this code gets passed. So obviously it will give TLE, but maybe like 500 600 test cases will be passed here, and we can see like it is taking a longer time to run, and eventually it will give TLE only, because yeah, so yeah, test cases were less, so it gave TLE on 25 test cases. So now how do we really means need to optimize this solution? So definitely like we'll need to query means loop through each of the queries. So big of m complexity will definitely be required. Now either for each query we need the answer in big of 1, or like suppose big of n is not allowed, so like big of log n maybe. Okay, so we need to find the answer for each query in either constant time or log n time. Then only we'll be like able to give an accepted solution. So what can we observe here? We try to make this observations that element greater than x, we need to decrease them, and element less than x, we need to increase them. So that means if we simply sort the given nums, so it was initially 3 1 6 8, and the query that we had, suppose it was 1, suppose query was 4. Okay, since if we sort this given array, will get 1 3 6 8. So now we'll see, like since it is sorted in increasing order, so there will be some point till which the elements are less than query, this q, and these elements will be greater than q. Hence we need to perform decrease operations here, and we need to perform increase operation here. And means what is the final output that we need? We need to increase it such that it becomes 4 4, and we need to decrease it such that it becomes 4 4 again. So these are the two parts that we need to handle. We can means move one part till like less than equals to q. Suppose there was a 4 also present here, and then the right part will be less than q, where will be means greater than q, where we need to perform decrease operation. Since like how can we identify what is the number of operations required to convert this array into this array? So for the increasing part, we know like the index till which means the number of count of elements count of elements less than equals to x. Suppose it is left count. Okay, so these many elements we are have which is less than equals to q. So the final sum will be what? This left count into q, right? Because for each element we have made it to q, so it will be simply what? 2 into 4 here. Okay, and now what was the initial sum? The initial sum will be the sum till like it will be sum of these elements. Okay, hence the number of operations will be simply the final sum that we have from this will be decreasing the sum of elements till this particular point. Okay, so suppose it is represented by I, so all the elements sum from 0 till I will be needing to remove them. Okay, so sum from 0 till I. So this is like the number of operations we need to perform to convert this part into 4 4. Now what about the part where the value is greater than q? So in that part we have the sum as, we'll have the means last sum. So it will be like sum from I plus 1 till n minus 1. Okay, and now we need to means the final sum that we need will be what? Number of elements on right, and the number of elements on right will be right count. This will simply identify it on the basis of indexes, and right count into what? Into the QL. And obviously like this sum will be greater than this, so since we are decreasing it, so we'll take the difference of them. Okay, so we'll be taking difference of these two values to find out the right operations. Okay, so hence we will find out the number of right operations as well as the number of left operations, and we'll simply sum them to identify how to convert the entire array to this array. Okay, so I hope like the logic is clear. Now the steps that we need to perform is, the first step is to find out I, means we need to find this index I till the elements are less than equals to q, right? Till the elements are less than equals to q. So that means we'll need to like find, if we find the first index such that nums of index is greater than q, then nums of index is greater than q, then we'll simply reduce this index by 1, and that will be simply the I that we need. Okay, so till this I, there will be the elements which will be less than equals to. So we can simply find it using either binary search, or we can use the inbuilt function upper bound as well. Okay, so once we find the upper bound, we will check like whether means decreasing is possible. This means index is not equals to 0, means index is greater than 0, then only we will be decreasing it, and then finding out the sum using sum from, now we need to find the sum from 0 till this particular I. Now again finding out the sum, if we like will traverse through the entire array to find the sum, then obviously it will again be of the order of n into m complexity. So this can be done in log n, but how do we find out the sum? So again obviously we know, like whenever we want to find the sum of a particular range of a non-changing array, we'll simply use prefix sums. Okay, so what prefix sums here will be, the prefix of 0 will be pointing to nums of 0, and prefix of I will be some denoting the sum from 0 till I. Hence if you also means, then we'll be able to simply find the left sum using prefix of I, and for the right sum we'll be needing the right sum. So suppose this was array 0 till I till n minus 1. So we need the sum from I plus 1 till n minus 1. So we need to, means if this is the entire portion till n minus 1, we need to remove this portion that we have. Okay, so what we'll do, the I that we have will simply like reduce the prefix of n minus 1 and decrease this part, that means prefix of I. Okay, so this will be like the right sum, and once we have the count as well, we will simply like find out the count of elements on the right, count of elements on the left based on this I, and then we'll be summing both of those values and after taking a difference. So this was the overall approach using prefix sums as well as applying binary search for each query, and then it will be running in n log n complexity. So let's see the code for this as well. I hope the approach is clear. So what you need to do, the first step is to simply sort the array so that the elements less than q are on the left and elements greater than equals to q are on the right. Now we create this prefix sum. So prefix of 0 is nums of 0. Now at each step what we'll do, we'll simply calculate this prefix value. I hope like by now we have done 10-12 questions related to prefix sums. So I hope this part is clear now. Now what we'll need to do, we'll need to return this vector long now. So we create this vector, and we'll be pushing the result for each query in this vector result. Now for each query what we do, we first find out the part, means upper bound will give us the first element greater than q. Okay, so the index will be, the index means the first, currently the index will be at this point I plus 1. So if this I is greater than 0, that means we can, means we'll have some valid portion here. If I is 0 itself, that means all the elements will be greater than q only. Okay, so then left sum will remain 0 only, and then the left count that we have is initially, since it is pointing to I plus 1, so that is the number of elements that we have on the left. So left count is simply I, left sum is initially 0. Now if I is greater than 0, then the sum will be stored in prefix of I minus 1. So initially I is here, so this will be I minus 1, 0 till I minus 1. And now the left cost will be simply left count into q minus the left sum. And similarly we'll do the right part. The right count will be n minus I, the right sum will be prefix of n minus 1 minus the left sum that we got, and the right cost will be, means decreasing the right sum, and since all the values are greater than q, we need to decrease it. So we'll decrease the part that we require, right count into q, from the right cost. So this will be, the overall result will be left cost plus right cost, and this will be the overall n log n complexity approach, as well as we are utilizing big of n space here. So this will this should get accepted because n can go up to 1e5 only. So this n log n will be till means approximately 1e6, big of 1e6. So let's try to submit this code as well and see whether it gets accepted. This is the same code that we discussed. Let's run it first so that I hope there are no errors in this. Yeah, it runs fine, and let's try to submit it as well and see whether it is get accepted or not. And as you can see, it runs in 161 ms, which is fair enough. Fair enough, and hence the n log n approach is the most optimal one here. So this was the overall discussion for this approach. Means the concept was pretty popular, using prefix sums to find out the range sum and finding out the first element greater than particular element using upper bound or lower bound as we desire. So I hope you were able to follow along with the approaches, and if you did, make sure to like as well as subscribe, and if you have any doubts remaining, feel free to comment down. I will be happy to help. Thank you so much for watching.